Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying Progressions lecture 3. So we'll be studying properties of GP and basics of HP in this lecture. Okay. So let's begin this lecture with a refresher example from the previous lecture. Okay. So we have let A and B the nth term of GP of positive numbers. Let this summation equals to alpha and this summation equals to beta such that alpha is not equals to beta. Then the common ratio is. So we have been given one GP a1, A2, A3 till A2n. Let's say the first term is A and common ratio is R. Standard, okay? Now what they've done is they have divided this GP into two parts, alpha and beta. So alpha is having the terms with E1 subscript, okay, A to N, where N is going from 1 to 100, okay? In this case, subscript is odd and also N going from 1 to 100, okay? So alpha is A2 plus A4 plus A6 till A200, okay? Now, if we want to write this in terms of A and R, what will be getting? A2 is nothing but AR, right? A4 is nothing but AR cube. A6 is nothing but AR is per 5 till, and this is nothing but AR is per 199. Okay. Now, if you want to write beta, beta would be A1 plus A3 plus A5 till A199, right? Now, if you want to write this in terms of A and R, we'll be getting A1 is A nothing, right? And A3 is AR square, A5 is AR raised per 4, and A199 would be AR raised per 198. Okay. Now you can see that this and this, both of them actually are individually a GP, right? They both are GP. But over here, the first term is AR and common ratio is R square. Over here, first term is A and common ratio is R square. Okay. So let's try to find out the summation alpha and beta. Okay. So alpha would be first term, that is AR, right? Multiplied by 1 minus R square, that is common difference, raised per N, that is 100, whole divided by 1 minus common difference, right? Now, if we talk about beta, that would be first term, that is A, multiplied by 1 minus R square raised by 100, because common difference is R square and number of terms is 100, and divide by 1 minus R square. Okay. Now, you can see that this term and this term is same. Also, we have A in common. What is different in alpha and beta? That is R only, right? Everything is same, but we just have additional R over here. So if you want to find out R, what we can do, that would be alpha by beta. Okay. And now let's solve this question. If in a GP of 3 n terms, S1 denotes the sum of first n terms, S2 denotes the sum of second block of n terms, and S3 denotes the sum of last n terms, then S1, S2, S3 are in AP, GP, HP, or none of these. Okay. So what they have done is they have given a basic GP of 3 n terms. So let's write those terms. So first term is T1, second term is T2, third term is T3, and we have nth term as Tn. Then we have n plus 1 term, n plus 2 term, n plus 3 term till t2n. Then we have t2n plus 1, t2n plus 2, t2n plus 3 till t3n. Now what they have done is they've taken this summation and this summation and named it as S1, S2 and S3. Now let's write S1 first. So S1 is nothing but A plus AR plus AR square till AR raised per n minus 1, right? Now S2 is AR raised per n plus AR raised per n plus 1 plus AR raised per n plus 2 till AR raised per 2n minus 1. Okay. And now S3, that would be AR 2n plus AR raised per 2n plus 1 plus AR raised per 2n plus 2 till AR raised by 3n minus 1. Okay. So we have n terms in this one, n terms in this one, and n terms in this one. In this case, if you want to write down the summation, we'll be getting A times 1 minus R raised per n, because common ratios are only, divided by 1 minus R, right? First term is A over here. In this case, first term is AR raised per n. We've got AR raised per n multiplied by 1 minus R raised per n, because common ratios are only and number of terms is n, divided by 1 minus R. In this case, what we have got AR raised by 2n multiplied by 1 minus R raised by n divided by 1 minus R, right? And now if you look at S1, S2, S3 carefully, you can see that S1, S2, S3 are also in GP with the common ratio of R raised by n, right? In this case, we have A. In this case, we have AR raised by n. In this case, we have AR raised by 2n. Basically, everything is common, but one thing which is getting multiplied over here, that is r is per n. So common ratio is r is per n. So S1, S2, S3 are also in GP. Okay. Now let's talk about properties of GP. And these are more or less similar to AP only, but with slight differences. Okay. So the first property is if ABC are in GP, then B square equals to AC. So we can simply say that when ABC are in GP, B by A equals to C by B equals to R, right? Common ratio. Now if we cross multiply them, we'll be getting B square equals to AC. Simple. Okay. Now, if we talk about the second one, the common ratio can be positive or negative, but not zero. Why? Let's say we have the first term as A. Now, if common ratio is zero only, in that case, second term would be zero, third term would be zero, fourth term would be zero, and so on. Right? Every single term after that would be zero only. Right? Now, if you take, let's say this is T2 and this is T3. T3 by T2 should be R, right? In this case, we'll be getting 0 by 0, which is not defined. Exact 0 by exact 0 is not defined. So that's why R cannot be 0. Okay. That's our second property. Now let's talk about third point, that is considering numbers in GP. Now, if you remember from AP, we chose numbers like A minus D, A plus D to maintain the symmetrical edge, right? To maintain the symmetrical edge over here, right? That would have helped us in problem solving. And this case will also maintain the symmetrical edge. So what we'll be doing, we'll be choosing three numbers like A by R, A and AR. If you talk about four numbers, what we'll be doing? We'll be doing A by R cube, A by R, AR and AR cube, right? So this is how you have to choose three or four or five numbers, whatever. Okay, maintaining the symmetrical edge. Now the fourth point says the product of terms of GP equidistant from the beginning and end is constant and equal to the product of first and last terms. Now if you remember from AP, we had the same property but for summation part, right? Over here we have it for the product. Okay, so let's say we have seven terms: T1, T2, T3, T4, T5, T6 and T7. So T1 would be A, T2 would be AR, T3 would be AR square, T4 would be AR cube, T5 would be AR is per 4, T6 would be AR is per 5, T7 would be AR is per 6. Okay. Now T1 multiplied by T7, that would be A dot AR is per 6. That is A square R is per 6. Now if you take 1 unit distance over here and 1 unit distance over here, basically multiplying T2 and T6. So T2 multiplied by T6, that would be AR multiplied by AR is per 5. Now that again comes A square multiplied by A is per 6. R is per 6. Okay. Now we have proved that property. Now the fifth point says if each term of GP is multiplied or divided by or raised to the power by the same non-zero number, then the resulting sequence is also GP. Now in this case, we don't have addition or subtraction to the GP, right? We don't have that kind of property, but we have multiplication, division, or raised to the power. Let's take the same example once again. Let's say we have AR square, AR cube, AR is per 4, AR is per 5, and AR is per 6. Okay. Now what we are doing, we are multiplying, let's say K over here. Now in that case, we'll be getting KA, KAR, KAR square, KAR cube. You can see that common ratio is not changing, right? But it's also a GP. You can see that we have a common ratio. We have a first term over here. Common ratio is still not changing, but still a GP, right? Now, similarly, if we divide by some number, let's say K, once again, if I divide by K, in that case also, first term is changing, GP is changing, but common ratio is still not changing and still a GP, right? Now, third part is we are raising this to a certain power. Let's say we are squaring it, squaring every term. So what we are getting over here, we are getting A square, we're getting A square R square, we're getting A square R is per 4, we're getting A square R is per 6, right? And so on. You can see that GP is changing. Common ratio is also changing over here, right? N terms are also changing. Everything is changing over here. In this case, common ratio is also changing. Okay. Now the last property is if A1, A2, A3 are in GP where each A1 is positive, then log A1, log A2, log A3 are in AP and its converse is also true. Okay. So let's say we have five terms over here: T1, T2, T3, T4 and T5. These all are in GP. So this is A, this is AR square, this is AR, sorry, this is AR, this is AR square, this is AR cube, this is AR is per 4. Okay. Now these terms are in GP. Now let's take log on each number. Okay. So we'll be getting log A over here. This is log AR. This is log AR square. This is log AR cube. and this is log AR is power 4. Okay. Now using the property of log, we can write this as this one is same log A. This one becomes log A plus log R. Okay. Now this one becomes log A plus 2 log R, right? And so on. I can see that log A is common in every term, right? So if we write down this in terms of AP, so let's say this is A, this is capital A. So this becomes capital A, this becomes capital A plus, let's say this number is some D. So this becomes capital D. Now let's say this is A and this becomes 2D, okay? So we can see that we have formed an AP over here, A plus D, A plus 2D. So when we have numbers in GP, and if we take log on every number, then we actually get an AP. Okay, and vice versa is also true. You can prove that. Okay, and now let's solve this example, and you can actually take this as homework. It's an easy question. Okay, so let's take that as homework. Now let's talk about harmonic progressions. Okay, and these are very closely related to arithmetic progressions. So let's say we have 5 terms over here: T1, T2, T3, T4, and T5, and these all are in AP. Okay, these all are in AP. Let's do one thing. Let's take the reciprocal of each of them. So we'll be getting 1 by T1, 1 by T2, 1 by T3, 1 by T4, and 1 by T5. Now, when we have taken a reciprocal of each of these terms, these all terms are in HP or harmonic progression. Okay, it's as simple as that. When there are certain terms which are in AP, if we take the reciprocal of that, that would come out as HP. Okay, very simple. So now let's directly jump into the problem solving. And in this example, we have if x equals to this summation, y equals to this summation, z equals to this summation, where a, b, c are in AP and modulus of a, modulus of b, modulus of c all are less than 1, then x, y, z are in GP, AP, AGP or HP. Okay. Now if you talk about x over here, x is nothing but 1 plus a square plus a cube till infinity, right? Because n is going till infinity. So we have 1 plus a square plus a cube. Now I can see that this is GP, right? This is an infinite GP. And also we know that modulus of a is less than 1. So common ratio is a over here, which is a fraction which is between -1 to 1, right? That's a condition for infinite summation GP formula, right? So x would be nothing but a upon 1 minus r, that is 1 upon 1 minus a, right? Similarly, you will get y equals to 1 upon 1 minus b and z equals to 1 upon 1 minus c, because y is in terms of b and z is in terms of c, right? And all of them are actually less than 1 in if you take the modulus, right? Now we have been given that a, b, c are in AP. What we have to find? We have to find the relation between x, y, z, right? But what is given? We have been given that a, b, c are in AP. Okay. Now if we take the negative, if you multiply -1 in all these numbers, that would still be an AP, right? We have studied that in property, that if we multiply some constant number over here, we are multiplying -1 over there. In that case, it would still be an AP, right? So if we take minus a, minus b, and minus c, that is also an AP, right? Now if I add one number, that is 1 over here in every term, that would still be an AP, right? Because of the property of APs. Okay. So we'll be adding 1 in each term. So we'll be getting 1 minus a, 1 minus b, 1 minus c, and that still gives us an AP. Okay. Now if we take the reciprocal of each of these terms, that would give us an HP, right? This is how we define an HP, right? It is reciprocal of the terms which are in AP. So if we take 1 upon 1 minus a, 1 upon 1 minus b, and 1 upon 1 minus c, that would be an HP. Okay. So that's why x, y, and z are in HP. So D is the correct answer. And now let's solve this question. And again, I'll give this question as homework because it's a brute force question, right? There is just calculation, nothing else. Okay. And now let me introduce the last topic of today's lecture, that is AGP, that is arithmetico-geometric progression. And as the name suggests, it's a mix of AP and GP. We'll be just looking at how it looks like and we'll be solving this in more details in the next lecture. Okay. So the first term looks like A. Second term is A plus D multiplied by R. Third term is A plus 2D multiplied by R square. Fourth term is A plus 3D multiplied by R cube. Okay. And so on, right? And when we want to find out summation of this series, what we do, we multiply the common ratio s and then we subtract the entire series with one another, right? And then we're able to find out the summation s. So this is a basic method on how to solve the summation for an AGP. We'll be discussing this in more detail in next lecture. So this lecture was till here only. Let's meet in the next lecture for AGP and other topics. Thanks for watching.